In this video, we'll delve into the world of output parsers in LangChain. We'll focus specifically on their implementation in JavaScript and Node.js. So the thing with output parsers, so they play a crucial role in structuring language model responses and extracting meaningful information. So by utilizing output parsers effectively, we'll be able to transform our raw text outputs from LLMs into well-organized and structured formats. So while language models like GPT-4 offer more advanced features such as weighting higher their system message to provide more reliable prompt outputs, it's important to note that using GPT-4 and system messages come at a considerably higher cost than using models like GPT-3 or GPT 3.5 Turbo. So it's important to consider the cost implications and evaluate whether achieving the desired result can be accomplished effectively and cost efficiently with alternative models to GPT-4. So that's what we're going to largely be focusing on in this video. So by leveraging the functionality of output parsers in Javascript or Node.js, we can sort of strike a balance between cost and our desired result. So making our application more efficient and cost effective, and frankly, be able to accomplish things that you wouldn't have been able to prior to the introduction of these LLMs. So now let's proceed to dive into some of the practical examples of output parsers in JavaScript. So we're going to be showcasing their implementation, highlight their benefits, and what they can bring to the table. But before we get into that, there's two main methods that an output parser must implement. So there's the get format instructions method. So this method returns a string containing instructions for how the output of a language model should be formatted. So these instructions will serve as the guideline for the output parser to transform the raw response into a structured format. So the next method is the parse method. So the parse method takes in a string which is assumed to be the response from the language model. So it parses it into a suitable structure, and this specific structure may depend on the requirements of your application or what you're looking for to have as a desired output. So now let's dive into some examples of the output parser in action. So the first example I'm going to show is the structured output parser. The structured output parser is useful when you want to return multiple fields in a structured manner. So it defines a schema for the output and extracts the relevant information accordingly. So in this example, we'll import all the necessary modules. We'll create an instance of the structured output parser. We'll define the schema with the desired fields that we want. In this case, we'll use answer and source. And then from there, we then can use the parser to format a prompt and make a language model call to obtain the response. So finally, once we have that returned, we'll parse that response using the output parser and retrieve the structured information. So in this second example, we're going to look at the structured output parser with Zod schema. So similar to the previous example, this parser allows you to define the output schema using Zod. So Zod's a TypeScript validation library. So the schema is used to validate and structure the output accordingly to whatever you need. So third, we're going to look at the output fixing parser. So this is a wrapper that incorporates another output parser. So if the first parser fails to parse the output fixing parser calls the external language model to fix any errors if there are any. Next, we're going to look at the comma separated list parser. So this output parser is handy when you want to return a list of comma separated items. So it parses the response and extracts the individual items from the list. In the next example, we're going to look at the custom list parser. So you can use this when you need to return a list of items with a specific length and separator. So this will allow you to define the desired length and the separator for the list. So next, we're going to look at combining the output parsers. So combining the output parsers enables us to have a combination of multiple output parsers, as you might imagine. So the way that this works is it takes in a list of parsers, extracts the combined output containing the fields from all the parsers. So these are examples just to demonstrate how output parsers can be utilized in your Node.js application. Depending on your use case, you might find one or two or three of these useful. Maybe over time you want to play with all of them. I just wanted to make a quick video demonstrating on how you can implement, the appropriate output parser for your given use case. So you can extract structured information from raw text output, and really that makes it considerably more meaningful, because as programmers, just having text isn't necessarily the response that we want. More often than not, we want that text to be in a JSON format, or maybe within that JSON format, we want it to be HTML or CSS or some JavaScript that layers in the interactive components of what we're trying to build. So this concludes concludes the introduction on output parsers. I will have more videos coming out on LangChain specifically where we leverage output parsers and use it in a more real life use case in an application. So stay tuned for those if you're interested. If you're interested in exploring more about output parsers and their implementation, I recommend referring to the LangChain documentation. If you found this video useful or informative, please like, comment, share, and don't forget to subscribe to the channel for more updates. Until the next video, happy coding.